Bernoulli distribution. So tossing a fair coin, toss a fair coin, and what is the distribution? What is the distribution of number of heads? So this is our question. So in a single trial, so heads in a single toss, in a single toss. So we have got right question mark here. In a single toss. So what is the distribution of number of heads in a single toss? So we can say that when we have suppose we have a single trial, so that means a single trial, so that means when we do a single trial, so that means there are two possibilities. So the trial can result in one of two possible outcomes. One of two possible outcomes. One of two possible outcomes, either head or tail. So that means the two outcomes. One is success, but here we use the success and failure. So we use two terms. That means one is success and so that is failure. So trial can result in one of two possible outcomes. Success means getting a head or failure is getting a tail. Now, the probability P getting a success. So what is the probability P of getting a success? So that will be denoted as small p. So, and the P is failure. So failure we denote it as 1 minus P. The sum of all the probabilities, that is denoted as Q. So you can write as X, random variable X having 1. 1 means getting a success, getting it ahead. So 1 if a success occurs. So you can write as if a success occurs. And X is equal to 0 if a failure occurs. So if a failure occurs, if a failure occurs, so that means X has a Bernoulli distribution. So the X, random variable X, has a Bernoulli distribution. Bernoulli distribution, that means P, probability of X is equal to X, random variable X. So that means you can write as P raised to the power X and 1 minus P raised to the power 1 minus X. P raised to the power X. So, and 1 minus P raised to the power 1 minus X. That means 1 minus P is the failure. So that is not occur. That means we can write this as P of x. We write as P of x. Sometimes we denote it as px. For particular cases, that means we are talking about when we put x equal to 0 and x equal to 1. So how to write this Bernoulli distribution? That means p x equal to 1. So when we put x equal to 1, so this gives us p into 1 minus p raised to the power 1 minus 1, 0. So this means equal to p. So getting a success, that means getting a head. And p, when we put x equal to 0, so x equal to 0, this means p raised to the power 0 and 1 minus p raised to the power 1 minus 0, 1 minus 0, so this gives us 1 minus p. That means probability of failure 1 minus p. So above we write these two things. That means probability p, with the success we noted a small p, and with failure 1 minus p. So for particular cases, that means when we consider x equal to 0 or 1. Now, what is the mean of this Bernoulli distribution? So mean, when we calculate the mean of Bernoulli random variable, first we take a Bernoulli random variable. So denote mean is denoted as mu, or you can write as expectation of x. So expectation of x, this equal to. So when we have because Bernoulli distribution is discrete distribution, so this is discrete. So we can calculate the expectation as summation of. We already write the formula in expectation. So summation of xi into pi, where I equal to 1 to n for general case. But here that means we can make a distribution. How to write the distribution? That means we have a random variable x and corresponding probability of x. So when x having 0 value, then the probability is 1 minus p. So one probability is 1 minus p. When we have 1, so the probability is p. So 1 minus p when x equal to 0 and p when x equal to 1. So we can write as this equal to, when we open the summation, so the values of this we denoted as x1, x2, and this values are denoted as p1, p2. So when you open the summation, so you can write this as x1 p1 plus x2 p2. So x1 is 0 and p1 is 1 minus p, or x2 is 1 and p2 is 1. So p2 is 1, so this gives us p. So that means the mean of Bernoulli random variable, which is p. Mean denoted as mu, or expected value x is equal to p. So you remember this. Similarly, you can calculate expectation of x square. So when you calculate expectation of x square, so you can write as xi square into pi summation of. So xi square, 0 square is 0 into 1 minus p, and plus 1 square is 1 into p. So this also gives us p. Expectation is also p. Now we calculate variance. So what is the variance? So variance you can write as expectation of x square minus expectation of x to the whole square. So this equal to p minus p square. P minus p square. So we can write as p into 1 minus p. P into 1 minus p. So we can calculate the standard deviation. So standard deviation is the root of variance. Root of variance is equal to root of p into 1 minus p. P into 1 minus p. So this is the standard deviation for Bernoulli. Okay. So now we take one example related to Bernoulli distribution. First, you understand that means Bernoulli distribution read only success and failure. So we can take an example that means if a coin is tossed, so what is the distribution of number of heads in a single toss? So distribution single toss, that means when we get a head, getting a head, so that is shown as the success, and getting a tail shown as the failure. So success probability is P and failure is 1 minus P. Success we also denoted as 1 and failure denoted as 0. So x equal to 1, random variable, that means if we get a success. Yeah, for tossing a coin in Bernoulli, tossing a coin, this is an example for tossing a coin, that means x1 or 0. Yeah, takes only two values. Yeah, takes only two values for one and only, that means success or failure. Read only success or failure. Either getting the that or not. That means x equal to 0 and 1, taking only two. Either success or failure. You can understand with the example. We can discuss one example also. Example, approx 1 in 200 Americans, American adults. American adult are lawyers. One American adult is randomly selected. So what is the distribution? What is the distribution of number of lawyers? Number of lawyers. So we write as with Bernoulli, that means approx 1 in 200 American adults are lawyers. So that is the probability P. So we write as Bernoulli with the probability P. So 1 in 200, that means 1 upon 200. The probability of success, that means in 200%, 1 is lawyer, so that means 1 by 200. So you can write as the Bernoulli distribution distribution. So what is the distribution for number of lawyers? We can write as X is equal to X. That means for successes, X is denoted as success here. This is for success, probability P for success, and 1 minus P for failure. So we can write as probability of X successes. That means 1 upon 200, 1 upon 200 raised to the power X into 1 minus 1 upon 100 raised to the power 1 minus X. Raised to the power 1 minus X. So that means 1 minus 1 upon 200 is the failure. So when in Bernoulli distribution, we write X equal to 0 or 1. So probability X equal to 1, surely success. So that means this will be, this is the Bernoulli distribution. So when you put X equal to 1, so X equal to 1 gives us 1 upon 200. 1 upon 200, and when you put X equal to 0, so X equal to 0, so that means probability of failure, so which will be 199. So 199 upon 200. So that means 1 minus P. So 1 minus P is equal to 199 upon 200. So we talk about the trials. Some other probability distributions. Some other probability distributions are built on the assumptions of independent Bernoulli trials. Independent Bernoulli trials. So for independent Bernoulli, such as binomial, geometric, negative binomial, negative binomial. So these three also follow the independent Bernoulli trials. For calculating the mean, for calculating the mean or expectation, calculate mean when we have unfavorable cases are 40% and favorable cases are 60%. favorable are 60%. So unfavorable, that means we can write as 40% cases are failure. So 40% cases are failure and 60% cases are that is unfavorable and 60% cases are favorable. So these 60% cases, that means we denote it as a success. Unfavorable, we denote it as failure. That means failure cases, and these 60% are success. Success. So for this failure cases, that means we can take random variable x is 0, and for success, we take random variable x is 1. So 1. So we calculate the mean. So while calculating the mean is equal to summation of xi into pi. So xi into pi, so that means when x is 0 and the probability of this, so 40%, that means 0.4. So this is 0.4. 0.4 and plus 1, probability is 0.6. 0.6. So this we can write as 0 plus 0.6. So mean is equal to 0.6, 0.6. So this is the mean. So that means 1 minus p, 1 minus p is 0.4, and success, which is 0.6. Now we move to the next, which is Bernoulli. Now using the binomial experiment. So before we start the binomial distribution, we